All right, folks, let's go through the solutions to the exitiquette on intermolecular forces. Please make sure you go over this very well as many times as you want so that you can grasp the content. Which molecule is nonpolar? CH3Cl or C8H18? Nonpolar means doesn't have positive and negative end. Of course, it's going to be this. Does C8H18 have larger or smaller London dispersion forces than CH3Cl? How do you know which one has the larger London dispersion forces? You have to look at the molecular mass. The molar mass of this is greater than this. So this one will have a larger London dispersion forces. Consider the following two molecules. Which molecule has a larger molar mass? Of course, if you calculate this, carbon is 12 plus 4, that's 16. But this is, carbon is 12, chlorine is 35.5 times 4. Of course, this is the largest, or this is the larger. Thus, carbon tetrachloride has the larger or smaller London dispersion forces than methane. Methane is CH4. Of course, you have to look at the molar mass. Definitely, this is larger than this. Okay, arrange these noble gases in order of increasing boiling points. Increasing boiling points. That means from the lowest to the highest. And if you look at them, look at the molar mass and look at the radius. The smallest is helium, followed by neon, then argon, then you have xenon. Which of the following molecules would show London dispersion forces and which would show dipole forces? So we have, these are the elements, or these are the molecules. So you have to choose whether it is yes for London dispersion forces or yes for dipole forces. All right, for nitrogen will go for London dispersion forces because it doesn't have a positive or negative pole, so it's not going to be dipole forces. Then methane doesn't have polarity too, doesn't have north and south or positive and negative. It's still going to be a London dispersion forces. But when you come to molecule of water, remember that hydrogen is having small positive charge. Oxygen also have small negative charge. That is, we call this delta T, delta plus, delta minus. A small change in charges. So that means water is going to be dipole. In the case of ammonia, ammonia doesn't have positive or negative like hydrogen and water does. So it's going to be London dispersion forces. All right, select the chemical species, the species with the highest boiling points. Now, looking at this, you have to look for which of them will have the highest molar mass. you see that molar mass play a big role in these intermolecular forces. So if you look at the molar mass of all this, iodine has the greatest molar mass. So iodine will be the best option. Okay, so I will also show you the reason why they say that.
In this problem, a molecule with the largest number of electrons, for example, the largest London dispersion forces, has the highest boiling point. Therefore, I2 is the correct answer.
Alright, select the molecule with the highest boiling points. Highest boiling points. Select the molecules with the highest boiling points. Thin hydride, SN H4 will be the one with the highest boiling point. The reason is?
In this problem, the molecule with the largest number of electrons, for example, the largest London dispersion forces, has the highest boiling point. Therefore, SNH4 is the correct answer.
Which among these substances exhibits the highest boiling points? The highest boiling points. Now, when you look at this, you have to determine which of them will have the highest hydrogen bond. And looking at the history of forming hydrogen bond, remember hydrogen bond is only formed between hydrogen, nitrogen, oxygen, and fluorine. All these four. So out of this, only water meets that criteria.
In this problem, the molecule that exhibits the largest amount of hydrogen bonding has the highest boiling point. O is more electronegative than S, Se, and Te. Consequently, the OH bond is more polar than the SH, SEH, and TEH bonds. Therefore, H2O exhibits larger hydrogen bonding than H2S, H2SE, and H2TE. Therefore, H2O is the correct answer.
What causes oxygen to have a higher boiling point than nitrogen? What is responsible for that? Of course, one of the dispersion forces. Remember, they are both elements, so all the elements will all have London dispersion forces. You can look at this. Ion-ion forces is between ion and ion. None of these form an ion. When we talk of ion, we're talking about a combination of two different ions like sodium chloride, chloride ion, and sodium ion. Transfer of electrons. Alright? These will form covalent bonds. They don't form ions. Oxygen don't form ions by themselves. With themselves, they don't form ions, they form covalent bond.
Since O2 and N2 are both nonpolar molecules, the only intermolecular forces that occur are London dispersion forces. The strength of London dispersion forces increases with the number of electrons.
HF has a higher boiling point than HCl due to larger blank. Remember, HF will form hydrogen bond. HCl do not form hydrogen bond.
Whenever hydrogen is bonded to either O, N, or F, hydrogen bonding occurs. Therefore, it is because of hydrogen bonding that HF has a higher boiling point than HCl.
All right, those are the 10 solutions. I think there are more than 10. Those are the solutions to the exit ticket. Make sure you go through this properly and then understand the context very well. Right, thank you.